Hello friends, so today we're going to look a topic called family over plane curve. Okay, so this is the family over plane curve. Okay, so let's see the first statement. What is mentioned here? It mentioned that for each given set of real number, this is the real number, and equation. This equation represent a curve in the xy plane. What is the meaning of this statement? Let's see. Here is given a set of real numbers. These are real numbers, and these equations, this equation including these real numbers and the xy. Okay, this represent a curve in the xy plane. This equation represent what? This equation represent a curve in the xy plane. Yes or no? And what is this c1, c2 by cn? These are the real numbers. These are the real numbers. So combining of these real numbers and the xy planes, this represent the curve in the xy plane. That is what mentioned here. So I'll give you the examples. Okay, I'll give you examples where I'll give an example here. Just look here. So first of all, here is example. Here is an example of a line, but I'll give an example. The circle is a curve. Yes, correct, because in the form parabola, ellipse, hyperbola, all these are the curve. Okay, so I'll give you examples. Okay, according to the statement, I'll write down in this way. Let's say this, I have a set including h, k, r, because here we have h, k, r. So I'm going to put it here. So it's a set of a real number including h, k, r. Got it? So n, we have a equations where x, y, h, k, r equal to 0. Okay, so this equation is going to represent a curve. What kind of curve? Circle. It's going to represent a curve in the xy plane. That's what's mentioning in the statement. Got it? So it's when it's given us set of real numbers including x and y, we form a equations. This equation form a curve, represent a curve in the xy plane. This is what mentioning in the first statement. Got it? And it said that for a different set of a real number, for different means when the set of a real number is different, when the set of a real number is different, the equations going to be represent different many curve, means infinitely many curves. Like example, when this set is different, the real number of the set is different, we are going to form a different, because it's represent the curve. This curve is going to be different. Like example, okay, here we can say that the set of a, b, c. This is another set. This is s1, this is s2. Let's say see, look, when the set is different, this set is different, right? And when the set is different, the equation also different. So according to the different equations, it form a different curve. That is what mentioning the second statement. Okay, for different set of a real number, the equations going to represent infinitely many curve. So this is the second statement. So till now you understand, right? What is the first statement and the second statement? So we are talking about a plane curve. Got it? So let's see here what is mentioning here. So the set of all this curve, okay, we have seen many curve like circle, parabola, ellipse. So we have seen many curves. So the set of all this curve is called an n parameter family of a curve. C1 by C2 are called parameter of family. What is the meaning of this? Okay, so I'll give an example here. Here is given examples. Example number 1. So it said that there's a concentric circles. What do you mean by concentric circles? When the origins, let's say this, when the center of the origin, this is the center, when the center is in the origins, it form a concentric circle. For different parameters, for the different parameters, we have formed different circles. Okay, So all these circles, okay, these are all concentric circle. These are all concentric circles because C1 is different. Sorry, this C1, C2, C3, like these are all radius, but different radius. For different radius, it forms different concentric circles. But all these are called as a concentric circles. Yes or no? Okay. So what about this? How about this? So the set of circles. This is the equation. This is the equations. This is the equation of circles. And how many parameters are there? We have many parameters. How many parameters? 1, 2, 3. Okay. Okay, sorry. I have to write down. Okay. So we have how many parameters? We have 3 parameters. C1, C2, C3. C1, C2, C3. We have 3 parameters. Okay. This is another examples. Okay. So when we say parameters, we have to check in the equations. Sorry. We have to check in the equations how many parameters are there. There's a 3 parameters. Whereas C1, C2, it takes a it can be any real values. Okay. And C2, like C3, sorry, C3 is going to be the non-negative real values. Because why? C is going to be the radius. C3 is going to be the radius. So the radius cannot be minus. It should be all non-negative real numbers. Got it? This is the second example. So I'll give you some more examples. Okay. So equation of a different circles. Okay. Yes, the topic is all about curve, but I'm talking especially for the circle. So here is the examples. See, let's see. See, I have 4 examples. See, I have a 4 example here. I have 4 example here. 1, 2, 3, 4. Okay. So okay, let me write down properly. I have more. How many examples? I have 4 example. 1, 2, 3, 4. We have 4 examples. So for a different center, when the center is different, these are the center. These are the center of a circles. When the center of the circle is different. When the center of this circle is different, we form different circles. And the equation also gonna be different. The equation is going to be different. The equation is going to be different. Yes or no? But the radius, here we consider radius as R. Radius as R. Okay, as R. So let's see the first example. You'll understand all of it. Okay, once you see the first example, you can relate all these 1, 2, 3, 4 examples. What is mentioned here? So it's given a center. Where is the center? This is the center. So center, we also can say xy, right? Yes or no? It is in the xy plane. So this xy equal to syk. This is what here. So this is the center. This is the center. So here R is the radius. This also radius, right? This right. All of these are radius. Yes or no? So we can say that this is same. And I consider as a R. Yes or no? So here, this is the height. This is the height. Okay, this is the value of the R. So what is the value of R? K. Because from here to here is K. From the Y, we know that this is the length of the what? R. R equal to, okay, so that's why here H and the K are the same here. Okay, according to this circle, H and the K are same. According to the circle, this H and the K are same. And when we see the radius, R, so R equal to K, K equal to H. So that's how it forms the equation of a circle, because this is the equation of circle. And I change this R square equal to H square equal to K square because of this. I'm putting in this way. So see, because of the center, we form different equations. What about if this circle is in this form? Okay, here the center is different. The center is not only positive. Here the center is all minus. So when it's form all minus, this all minus when it's combined, it become plus. See the difference. See the difference. It become minus here, plus here, plus. See, because of the center, means because of the parameters, because of the like the set, because of the sets is mentioned in the first statement, right? Because of the different set, it's going to form different curve, right? So that's why it's going form different curve. So like this, here also you can look. Okay, here you also different centers. Okay, the height and the k are not same. The height and are not same. So because when it's not same, it form different curve. Yes or no? It's also here when the center is different. Okay, it's form a different equations. Yes or no? So that means when the circle, see, let's see again. I have how many circle? 4 circle. I have more 4 circles. According to the different centers, we have formed different equations. We have formed different equations. Different equation over different circles. So this is the equation over different circles. Now you understand, right? This is the first example. So I'll give you one more example. What about even I mentioned about this? When the center, this is when the center is at origin. When the center is at origin, this is the center at origin. This is called center at origin. So it formed for what is the equation of this? X square plus y square, because the heights and the k become 0 already. That's how it formed the different equations. This another equations. But what about if center is in the form? Means might be the circle might be here. Okay, because the x and the y is in the positive form. So this is a different form of this. When the center is in this way, we form different equations, because height is equal to height is equal to 2 and k equal to 3. That's how it forms. And the third examples, when the center is in this form, we form different equations. How? The height becomes -2, k becomes 3, and now it's formed. That's how it's coming here. Correct? That's how it's formed the different equations. Here also the same. When the center is different, we form different equations. See, all these equations are same? No, all these equations are not same. Because why? The center is not same. The center is not same. So when the center is in different places, the equation, the circle, is in the different places. The equation also different. Got it? So this is the example of the different circles, and it is within the different curves. Okay, this is what I'm mentioning here. So I'll repeat you once more again. Okay, so the family of a plane curve, so that the real number, this is the real number for the different equations, it form a different curves. Different real numbers, different equations form a different many curves. The example I've already given. Different sets of real number have formed different equations, and different equations have a different curve. Okay, so for today I'm going to finish the topic here. So I'll be solving more questions about different curves, okay, different ellipse, how to find out the different equation of a given all set of the circle or maybe ellipse. Okay, so I'll be taking these like examples in the next video. For today I'll be finishing here. Thank you.